Good morning. I know that some of you are still in the lobby. Maybe we can wait for a few minutes. Okay, actually, let's get started. I could see that there are fewer of you this morning than there were yesterday. Maybe you had a very nice evening last night. We talked to a number of people, and they told me that it would be a good idea to explain why the journal format changed. It's thought that it'll make things more difficult with V14, but clearly we have primary keys for the tables that we want to journal. And for those who didn't have any, then you have to think about putting some in, and you have to ensure that they're valid. It's a bit of a disadvantage. However, there are lots of advantages, and that's what I'll be exposing to you. This is a technical presentation. It's to explain the internal format, explain what's going on, and explain the new journaling system that will enable you to have a safer system, better control of data. So, briefly, I've prepared an explanation of the format of the journal. I'm not going to get into details, but we have a header, 4 bytes, to communicate that it's the entry of the journal. Then there's an operation that indicates which operation will be executed, a length, and then according to the type of operation in the journal, then there are different sizes for the files, and then once again you have a length and a footer tag. The idea is that the journal can be read both ways. That's why the length shows up twice, at the beginning and at the end. We can go through the journal from the beginning to the end or from the end to the beginning, and we can even start in the middle and try and find missing operations. This will allow us to do a number of things that I'll be explaining now. What was this? Log file?
Mm-hmm.
There are a number of changes that were made, but let's just say that there were 6 main changes. One of the things is the operation counter. Every time an operation is put in the journal, we have a counter to be sure that we're synchronized, that the data and the journal are synchronized. If ever there's a crash and you haven't saved part of the data that's in the cache and that's already in the journal, then when you start up again, you can find the last operation that was saved and to resume operations. The problem is that all of the operations increment the operation counter. Now, only the operations that change the data actually increment the counter. That has many advantages. It means that you can open the data 50 times without changing the counter. You can look at the journal without being desynchronized, and there are a number of other advantages as well. As I said earlier, we use the primary keys to reference a file as opposed to the number of the file. I'll explain this a little bit later. It means that it won't be possible to journal a database that doesn't have a counter. There's a memory buffer or a temporary file if there's no more temporary memory. and it's recorded in the journal only once they are committed, which wasn't true before. Before, the transactions started to be recorded in the journal as soon as the data was modified. So you would carry out a transaction, you had a file, and there would be a journal entry. And if you canceled the transaction, there was an entry in the journal that said that the transaction had been canceled and the transaction wasn't taken into account when the journal was reintegrated. Now, until the transaction is committed, because only committing to the transaction counts, until the transaction is committed to, there isn't an entry into the journal. If I cancel the transaction, there isn't anything written in the journal. And I'll explain why that has advantages. I showed you the format of the journal that enables you to go both ways, front to back and back to front. And we spoke about this yesterday, can select the tables that will be journaled. Meaning that you can have journals that keep track of error logs that aren't journaled because we don't want to mirror them. You can also have temporary tables that we can use for calculations that are often modified, but at the end of the day aren't very significant in the end result. They're only used for intermediate calculations. You bring in data to process them at the end, for example. Well, we don't necessarily want to journal the intermediary steps. All of these modifications will allow us, with a sixth change in the journal format, to integrate a journal that wasn't necessarily created with the data that we would like to use to reintegrate it. And now you may be wondering, well, which data? That's what I'm about to show you. It's not in the same order, but the fact that the operation counter is incremented only for operations that modify data allows you to better manage the mirror, whether it's manual or automatic. And in this presentation, I'll often be talking about an automatic mirror. It's a product that's in the pipeline. It's not in V14 yet, but it'll be implemented, which will be automatic management of the mirror, and that will enable you to not have to go through manual processes to recopy the journal. We'll have a connected, or a mirror that's connected to a 4D server, and that will query the 4D survey to recover operations at a regular interval. It can be every minute, it can be every hour, or every several hours, and that way you can continuously integrate the mirror and do that more effectively, but I'll come back to that a little bit later. The fact that you're only counting operations that are significant in the journal allows you, well, let's take a very simple example. You have a server, you've done some work, and at a certain point, you want to give the journal to the mirror. The problem is that in the meantime, if I've reopened the data with the journal open, it's added an operation in the journal with versions 13 and 12. That's the way it was. If I close the data, then an extra entry is in the journal as well. So at some point, the journal will have a number of operations. For example, I could be at operation 123. I've copied it, I'm still at operation 123, and in the meantime I've opened my data. I'm now at operation 125 or 126. I've tried to integrate my journal because I've had a problem and I wanted to recopy my data, and from then on I'm desynchronized. So now only the operations that modify the data are taken into account. When you want to string mirrors, we spoke about this yesterday, then you have a main server and a first mirror. Within that first mirror, we learned that you can have a journal as well, which will continue to increment operations. Only those operations that modify data are taken into account. So if the journal was opened more than the main server, if the data were opened more often or less often, there won't be a counter desynchronization, because in any case there isn't any addition. There isn't any addition to the journal entries, and so you can take my journal file, pass it on to a second mirror, which will also be able to integrate data. Even if you've opened it 10 times in your first journal, then your second journal won't take that into account and will only include the lines of the journal that actually modify the data. We're not trying to sell you more servers. That isn't the idea. It's just nice to have two of them. I just wanted to explain how the journal operates. Sorry about that. All the slides are in English. I was a little bit lazy. I didn't put them in French, to be completely honest. So we start with 1. When you open the database, then you move on to 2. If you closed it, it moved to 3, and you opened at 4. Now, the counter stays at 1, and it's only a record modification or a record addition that counts in this example. It's just a quick table that explains what's going on internally. A second point, which will be the most challenging to implement for you in V14, and that's the use of primary keys. It's true for the journal, but it's also true for many operations in Wakanda, or rather in 4D. You're trying to be as close as possible to the Wakanda logic. We want a safe way of identifying a file. The number of the record isn't necessarily a safe way of doing things, because you don't have 2 records with the same number. The problem is that it isn't specific to time, so if you destroy a record and you create another record, it could take up the same number, and that causes problems. So the advantage of a primary key is that you're the one controlling it. Either the primary key is self-generated, or it's a sequence number, a 64 with a sequence number, and there you have it. Every time it's incremented, it's fairly clear. Either it's a number that corresponds to nomenclature or to what the client would like, but in any case, we're sure that it identifies the record in a unique way, and that's significant. When the record is damaged, and that can happen, in an ideal situation, there aren't any problems, it doesn't crash. In a less ideal situation, the server crashes, the data is damaged, but I have my journal and I can recover the data. And there are other things that happen more often than you would think. Some people keep their journal on the same disk as the data, which I wouldn't advise. And in that case, the problem doesn't have anything to do with 4D for once, but is linked to the hard drive. And in that case, you have your blocks that are damaged. Sometimes it's recoverable, but sometimes there are pieces missing, and you'd like to be able to recover as much as possible. In that case, if you use number records, so you have a record that has A, B, and C in certain fields, and I create number 10, number 11, number 12. If I modify 10 and I replace it by A2, B2, and C2, I do the same thing for record 11. If I would like to reintegrate it and the journal is complete, no problem. That's currently what is going on. However, if there's an entry missing in the journal, because I wasn't able to recover the full journal, which was damaged, I'm already explaining the new way. Maybe I've gone a little bit too quickly, but instead of storing the record numbers in the journal, 10, 11, and 12, you keep the primary keys, so you have X, Y, and Z. And when you modify the record with primary key X, then you have A2, B2, and C2. It looks like I'm missing a slide. I don't know why. It looks like I'm missing a slide. I guess I'll just explain it. Too bad. I'm just trying to remember what was on that slide. Let's say you're missing entry 1 in the journal. Creating record 10 wouldn't be possible. When you create record 11, according to the old way, the number 11 will become number 10 because number 10 hadn't been created. That's if you're trying to recover a partial journal. But you'll say that it isn't possible to recover a partial journal. You're right, it is prohibited for that reason. But with the new way, and the new version, you will be able to do so. But if you tried with the old version to recover partially, then you would have had 11 that would have become 10, the 10 that would have become 11, and instead you would have A2, B2, and C2 instead of D2, E2, and F2. At the same time, you can put D2, E2, and F2 instead of GH and I. So I haven't lost the data in that I've lost part of the data. It just corresponds to my business logic. I've lost the data, I've lost, I guess, a good chunk of my data. With the new way, you can create a record with your primary key, X, Y, and Z, and if you modify record X, which doesn't exist, and now you're in recover mode, you're in repair mode when the journal is damaged, a record that doesn't exist can be recreated. You can recreate X by putting in A2, B2, and C2, and you can modify Y by putting in D2, E2, and F2. Now, it isn't perfect because the fact that you've modified a record with a primary key that's X with A2 and B2 and C2, well, there may be other fields that were created in the first operation that aren't updated. However, the rest of the records will be fine. You'll be able to recover them fully. And really, this is a last resort, but it is very convenient. There were a number of cases where we would have liked to have had this function. Jean will remember this. We spent quite a bit of time on it. He was able to recover data a week later through a damaged journal. At the end of the day, he had to re-enter a number of data entries to resynchronize the files and the records. It was a manual task that took a full day just for one journal. That isn't something that can be done at an industrial level. You had to use a safer system, and that's why we prefer this new way that enables us to recover the data as a last resort. If you have your backup, if your data is on another disk, and if you have a mirror, then it'll happen even more seldomly. I'm just going to come back to the primary keys because there are other advantages. Now, the fact that the transactions are recorded in the journal only once, that enables you to have a journal that can be queried in small parts. That's the case for the new automatic mirror that we're trying to implement. When we'll have this mirror that will be continuously or regularly querying, of course you can select the frequency. You can query the server and ask for new operations since the last time that I've queried you. And so the mirror will keep track of the last operation that's been integrated. And the main server will send to the journal the relevant operations. If we had kept keeping the transactions as soon as they're started, these transactions would have been half sent to the mirror, which would have had to try to integrate them without receiving the final half. So you're keeping the operation outstanding, if you will. You're waiting for an operation that can happen an hour later or a day later, according to the journal frequency that's been selected, in order to be able to confirm it or cancel it according to what was done on the main server. So that can be a disadvantage. It monopolizes, and if for some reason the mirror is turned off, then the transaction is cancelled. If I start up the mirror once again, let's say I've had to turn it off for a given reason, maybe it isn't for a crash, but just for maintenance reasons, or someone had to vacuum and someone unplugged it, there are things that can happen. So you turn it on again, you reconnect to the server, and I ask for the operations that have been carried out since the last time. Well, the server will send you the operations since the last time. The rest of the transaction and other things will be sent. Now this remainder of the transaction will be sent in a context where the mirror it hasn't remembered what was done and what wasn't done. Now with the mirror, you can try to come back to find the beginning of the transaction because the mirror can have a log itself, but it isn't very effective. It's better to try to have the transaction sent atomically in the journal. So when a transaction is written in the journal, we're sure that it's been confirmed and all the data is there. Meaning that when the mirror queries the main server to say, can you send me the information, either have all the transactions or nothing at all and wait for the next time to have the transaction if it's been confirmed. In that way, we're sure that the data is fully integrated. It also avoids the journal getting, I was going to say too big, but there were cases where people start up transactions that they cancel later on. It enables them to do user interface, so they start a transaction, they can always modify anything they want, but often it's canceled. Why? Well, why not? I mean, that's not necessarily why I would have selected a transaction, but that's how it happens. But the problem is that that's logged in the journal. And when you have to integrate the journal, when there's only 5 or 10% of the transactions that are really relevant, then you end up with all these transactions that are reintegrated and then canceled, reintegrated and canceled. That way you can save a lot of time when you want to recover. Point 4. With the previous points means that the journal isn't necessarily strung. We often talked about the journal being strung. Journal 1 integrates the log through new commands, and then there's the second one that reintegrates the first, and so it's strung. But you can also imagine a solution where you have the main server, you use the new mirroring software that we'll be making available with 2 mirrors on the same server. One that will query at a 1-hour interval and the other at a 5-minute interval. They don't even have to be synchronized. Each will keep track of the last operations that were requested. The first one will be at operation 100,000. The second one may be at 99,000 because that second server hadn't requested as many or requested them a long time ago. And so it's done separately with 2 mirrors. And in order to do so, in order to be able to send the correct information, the journal has to be easily browsed on a disk, meaning that you can find an entry quickly and take them sequentially afterwards to be able to send them. However, when the journal is working and reading data, it has to be able to add new info because in that time the server is operating, and so people will add files, modified files, take files, and so on. The fact that you're browsing both ways enables you to save some memory on the server because you're not going to keep track of every single entry in the journal. According to the size of the journal, you keep a table where by dichotomy you can quickly find a specific entry in the journal even though it's very large. Even though it's 100,000 operations, you can find it very quickly. In order to do so, you position yourself just about where you think you should be and you look just a bit to the left or just a bit to the right, and that way you can look both ways. And that's the idea behind this new technology. It also enables you to, something that isn't mentioned here, but the fact that you can browse both ways means that you can position at the end of the journal and read the operations backwards to see what the last entries in the journal were. And that can be very convenient when you want to be synchronized with the data in the database.
So I mentioned it before. The fact of the selecting of the table actually makes it possible for you to be faster with temporary tables. Every entry in the log file is going to take time because it's written on the disk much more regularly than with the cache. So it actually, well, I mean, if the disk is not the same, if the drive is not the same, then the one where you store your data is not going to affect the flow rate with your cache, and the reintegrating, the re-embedding of it is going to take time because there's a number of tasks that are going to be destroyed, that are no longer relevant, because data is no longer relevant, so that saves time. Well, it's not necessarily the best way to put it. Integrate the log file or the journal from another data file because it was not necessarily created with the same key as the key you used for the log file for the journal. We have a data file. We created a log file, and that data file has several IDs. There's an ID that links it to the structure, and there's also that data file also has an ID that links it to the log file. And every time I create a new data file, it comes with a new ID. So I keep the structure ID, but there's an additional ID that is specific to that data file and makes it unique. So when I create log files based on those data files, I can be sure that the log file will be linked to the data file. And that's important if following a crash, you want to recover your data file. For example, let's imagine that I have a few operations that have not been stored in the data file, and there's a power cut, or sometimes it happens that servers crash. So it has not been created in the data, but it's in the log file. So you open it, you position yourself at the end, and thanks to the format where you can read it back to front or front to back, you check that the log file actually matches this data file in case someone moved it. And you have to be absolutely sure that the log file matches that data file. But if I want to be a bit more flexible, it could be that my mirror does not have the same ID as my data file. If I created the mirror file the way we usually do it these days, I just duplicate my data in the mirror file, and then I integrate my log file. So it's going to be the same data in the end. But with the new system, this new mirroring system that we are putting in place, you start with a data file, and the first thing that the mirror file is going to do is try to get all the data from the server. So the data is going to be exported as a compressed backup. So data is recovered and integrated. So it won't bear necessarily the same number, the same ID. Well, why not copy the data the way we usually do it? Because in the mirror file, you can keep tables that have not been put in the log file, and you could lose these tables. You don't want to lose these tables. For example, I want to keep error tables in my log file, and I want to keep my error tables in my main server. Of course, those error tables, I don't want to transfer them onto the log file. So if I recover the data, but I don't want to lose these tables, but I don't necessarily want it to be the same data being copied every time. So that gives you more flexibility. So I don't check the ID of the data, and I recover the data I'm after. Well, you have to be careful using this, because you could end up with a basic log file that has not at all the same structure, which wouldn't be a disaster because the table ID are not the same, but it could be dangerous. We've planned, actually, since I finalized these slides, we gave it some thought, and Jean Laguerre, who's in charge of product quality, said, well, that's a bit too dangerous. The fact that you can integrate a log file as you want, there's no control. What if there's a user error? So he told me there should be a way the developer can still have some degree of control. So what we've done was to, we started off adding parameters. So we added integrate journal, integrate log file. So that feature to integrate the log file. For those of you who had v14 beta, you saw that there were additional parameters. We actually removed them, and the log file is operated exactly in the same way as in v12 and v13. But we have added a new feature, which is integrate mirror journal, which makes it possible for you to work on a log file that is not necessarily linked to the data with an additional parameter, which is a whole number in 64 bytes. And it's the last integration counter that you used when you integrated that command. So when you want to integrate log files manually, you want to do your mirroring yourself, you can trace the mirroring, and you can use a text file or a JSON file, and you store that info, and next time you want to integrate, you're asked to integrate, you can recover that info and make sure that it's the right log file in the right order. So let's say there's a server. I have a server and I have 3 log files that I want to integrate because I've decided that I wanted my log files not to exceed a certain size. So I have those 3 log files. I have not integrated them in the mirroring files. So let's imagine that I get the order wrong. Instead of doing 1, 2, 3, I do 1, 3, 2. Well, let's say that I gave 100,000 as my last operation. Number 2 will be refused because I'll be told that it's not in the right order. Because log file number 2 was supposed to start at 120,000. So with that control, you can make sure that the user is not making any mistakes if the user wants to integrate the log files manually. So it's a security. That's the end of my presentation, but I have something else I'd like to explain about the primary keys that I mentioned before, and about their advantages, actually. Well, it's helpful with the log files, we saw that, but it's also helpful for many other things in 4D. There are going to be changes over time, but another thing where you actually need primary keys, where they're required, is for the REST server. You need to be able to identify a record that we call an entity in REST and make sure that it's the unique record you're after. Well, it's unique, but not unique in time. So the point with that primary key is that in REST, you are certain that you're using the same record. So in the near future, we're thinking of going further, because currently, when you have a selection of records, what's kept in the selection is the record number. Works pretty well, but there could be cases where I have a selection, I've deleted a record, and I've created another one, and it bears the same number, and it's part of my selection. That could be a problem. So that would require additional checks. So to address this, there's one thing that you can do, even not thinking of primary keys, which would be to say that when I delete a record, I want that record number to be blocked for a day, a month. So you can decide that these record numbers can't be used for the next week or month. And that is a way to solve the most common problems. So you won't find yourself with that record number in the selection. So that solves a lot of problems. But there are other cases when you want to be sure that you have a selection that can't be altered over time. So we've planned for this in one of our next versions, to have a selection that's based on primary keys. Well, there's a major drawback, which is that they're way slower, because the current selections are very fast. I think Jean-Pierre probably mentioned it. A selection, when it's not sorted, it's a bit table. 1 when it's there, 0 when it's not. So if I have 100,000 records, I have to go through the 100,000. Well, it's not too big, so it's pretty fast. It's binary. There are lots of advantages. Once it's been sorted, it gets a bit bigger, and you find yourself with your record numbers in the right order. So either the bit table or the record numbers. I can get the record number directly. Once when we actually make it so that the selection is based on primary keys, you will have to actually run a query to find the primary key every time. So it will be an indexed search. So it will take more time, but it would be very good to have when you want to be sure that your selection can't be altered over time. Well, I've digressed a bit, but I really wanted to explain clearly that primary keys, I observed it myself. It's not going to be a major problem, but it's going to make things a tad difficult when you have a big database with 200 tables. Had we not put primary keys, it wouldn't have meant that we wouldn't have had fields that actually served as primary keys. It's very often the case. Those fields behave as primary keys, but we had not defined them as primary keys. So 4D can't find that out. So as of V13, you have a tool that goes through all your tables and suggests to you what you could use as a primary key. Well, if there's a primary key to begin with, it's not going to suggest anything. But if there's no primary key, it's going to look for a single field, a unique field. If there's only one unique field, it's probably going to serve as a primary key. If there's a field that is the target of your links, which is the root of one too many, it's probably going to be used as a primary key. If there's not a single field that looks like it could serve as a primary key, then it's going to suggest that you create a primary key, either with a digital field or a UID field. And the good thing about this is that you have to populate the data with the values in this field incrementally or by generating automatic IDs. So if you have a structure as a developer where you've set up everything and you know that where there are primary keys missing, you can add them, it's self-generated. But when it gets to the client, first conversion from v13 to v14, so you run it, and it checks if there are primary keys on the tables, and it checks if there are no primary keys, if we had added some in structure. And I'm at home as a developer, and there's a primary key that I'm going to call ID. It's an auto sequence number. So I set it up at the customers. So it makes for a smooth migration, but it's no magic remedy because you often have fields that can serve as primary keys. And since primary keys are becoming more important, we've strengthened the checks and controls. It's a bit like road safety, you know. So we've strengthened the controls. We check that all values are unique and that there are no values that are null. Supposedly in 4D you can't have values that are null, but it's not exactly true. One of the cases when you can find yourself with a null value is you take a field, you add it, and if you already had records that did not have a field, the field was never entered. So in 4D, it's considered as null. So the first time I open that record and access that field, it's going to be converted on the fly as 0 if it's empty, or something else if it's full. But until it's been converted, it remains null. So we had created 3 or 4 records at the start, and we thought, well, I need a field that's going to serve as a unique value as a primary key. I can add it. But unfortunately, there can be cases where this field is a primary key with null values or non-unique values. Well, it can't happen on your database when you actually set the structure. When you're in the structure and you're thinking you want a primary key. No, that can't happen then. But if you give your structure to a client in V12 and V13, there's no additional check, no further check. So a client can have values that are not unique or that are null, and the primary key is accepted. But that changes with V14. When you change in the structure and there's a new field, the first thing V14 does is to check whether it matches. The check occurs every time there's a change. It can take a bit of time, because if you have 1 million records, it's going to take some time. But there's a progress. You can actually get a progress stamp. So that's what I wanted to share on primary keys, bearing in mind that we're going to use them more and more. Well, I actually thought I would speak for 30 or 40 minutes, which is usually the case in the US. I was given an hour and 15 minutes, so that's great because we have plenty of time for your questions. Yes, good morning. I had a question about how frequent backups are, for example, if I want to create a mirror file every 30 minutes, and I want to create another mirror on another site, and occasionally I want to create a third mirror file on another site, and I want to back up, I want to save every 10 minutes or so. It means that it would have a different frequency on all three sites. So is it going to try and recover in previously archived log files so as to reconstruct, when I run the query, a complete log file that will aggregate all of that? Yes, it's almost that. If I back up and I close my log files, with our new mirroring system, our new mirroring products, the main server will know that it's responded to a given query. So it's going to keep this info, it's going to duplicate the query that was the most remote from the mirror. And as long as there hasn't been any query, it's going to keep 100,000, for example. But then the most remote one is going to become the 120,000 and not the 100,000. So that information will be kept in separate files that we have nothing to do with the backup. And they'll be destroyed regularly once they've been sent to the mirror. But the idea was that what can the problem is that when there's a backup, the system can't be used anymore for another task, and the backing up data actually can take time. So the idea was not to back up the main server, but to have backups of the mirror files, not of the main server, so that the main server is never disrupted, and I only create backups of the mirror. And I can even use the mirror as the main server and create a second mirror. But actually creating the backup from the mirror will probably be the most convenient solution, because it saves you from actually blocking the main server. Yes. I wanted to know, can a primary key be a composite index? Yes. Actually, it's already the case. A primary key can apply to several fields. And I think the interface is included in the structure editor. In SQL, you can definitely do it, but a primary key is not linked to one field. It can be linked to several fields. And a second question, in V14, we were told that there would be a check that the primary key is indeed unique if you change the structure. That's what you said. Will it happen only if there's a change in primary keys, or for any modification in a structure? No, only if there's a modification in the one table where there's the primary key. Yes. Good morning. This idea that you explained of a different use of primary keys could be in a network where you have, for example, sales reps that are on the road. They have a copy of the database when they go, and if they add or modify data, could we do it in the opposite direction? That's to say, recover the system in the main database with the journal, with the log file that comes from the mobile device? Well, I expected that question because people always dream of having the synchronization both ways. I'm afraid I'll have to crush your dreams. It's not going to work for different reasons. First, because if I update, well, when I say it won't work, it's not exactly true. It all depends on the type of work you want to do. If your sales reps or salespeople work on different records, but they would have to be different, then it would work. So, but it's a specific case because quite often in a database, there's not only one table, there are different tables, there are links, you update, etc. But here, in your case, every time there's a record, there'll be a conflict. If you integrate them in a certain way, you could imagine a possibility of actually solving these conflicts, but it's going to imperil the integrity of the data because the second modification can apply to an X field, but it's still going to alter the whole record. And it's going to collapse the whole record. So it was not designed for that purpose. So I'm always asked, can the synchronization go both ways? No, unless our salespeople have very distinct sectors. Yes, but you'd better do it your own way with different routines, reduplication, or using SOAP and send out orders and resynchronize, or you put it in a text file and you import it. But better not use the log file. But I'm kind of lazy, so that's why I thought of that. Any other questions? Well, one more thing which is important. The replicate, as we put it in SQL, was not designed to be used as a mirror file or as mirroring. And it could be actually a bit dangerous to use it for that purpose because it seems a bit magic, you know, to begin with. I have all the modifications made to my table, and if I use a replicate, it's great. Well, yes, it's all very well, but it all works table by table. So very soon it's going to cause problems with the logical integrity of your data. For example, I have commands and I want to use one command to create a mirror. So I use the command table, I copy everything, but one was entered in the meantime, so it's not going to be part of what I copied, and I find myself with the copies without the command, or the other way around, I could find myself with commands without the actual copies. So you could argue that it's not a problem because with the integration that would be solved. But I would find myself with those commands, and if it's the other way around, then I get my missing command. But if it's supposed to be used as a backup, as a mirror, and that the main server crashes, and I want to try and use it as a mirror to be able to use it again, find myself with data that is no longer consistent. And what's worse is that data is not consistent in your business logic and as part of your integrity, but they are consistent in a certain way. They're no longer linked to a certain command. So you could think you have good data, but actually you don't. So really, you shouldn't use replication to create mirrors.
Okay. Je peux répondre à deux.
I can answer questions that aren't related to mirrors if you have any. before with backups, we could skip operations before reintegrating the mirror. We could skip. We were talking about this yesterday with developers who would like to be able to cancel, for example, if they've deleted 100,000 records, but they've continued to work until 5 o'clock in the afternoon, can you roll back? Well, if you're using primary keys, I didn't want to speak about it too much now, but okay. I guess we can reveal a bit more than we had expected. It isn't for the near term, but at some point we're seeking to develop a series of tools to try and recover not only system errors, but user errors, and only reintegrate a part of the journal, but that you would select. In that mode, there would be a number of options like skipping operations. And the idea behind a primary key is that even though I've added records, it won't break the rest. So you can imagine someone who's created a record that they didn't want to add, then you can skip that operation and it doesn't break the logical structure of your data. Just to come back to mirror systems, the current system works in the following way. You have a new file history that you define every minute if you'd like. And on the mirror, you do integrate historical file. And so the transfer is done through technology that we've implemented either through SOAP or FTP. But in your explanation, you were saying that the mirror base is going to query the main base to determine where we're at. Well, that'll be done with a new tool, with a new product. Will that be a new product? For example, before we had 4D backups. Okay, I don't want to reveal too much, but that'll be a 4D server that'll be serving the mirror. And this 4D server will have a special mirroring mode. I don't really know how we're going to call it. We haven't defined it yet. But that would be a 4D server function, or would it be an additional product? It would be a function of the 4D server. And now, whether it's a new product or not, I don't know. I don't take care of sales. Other people take care of sales. Really, that isn't my cup of tea. But from a technical perspective, so it'll be easier to implement than what we have now. Right, exactly. What we're trying to do is simplify things. We're starting this 4D server mirror. We're saying connect to the main 4D server, and that's it. It does the synchronization itself. And we have a number of parameters like frequency. If you'd like backups, you can do backups on the mirror as well. What you're doing now will continue to work in the future. Even a manual procedure, well, manual isn't really the right term because I know that you've made things and you've made it automatic through code. But in V14, what you can do is that the mirror itself has its own journal, meaning that it can be reused immediately if there's a problem on the main server. And a final question. Currently, on the main base, either you do mirroring or use the conventional saving operation. You can't do both at the same time because otherwise you'd have a journaling problem. Currently, with V14, will that still be the case? Or will we always have that restriction? You're right. In a way, there is a logical restriction. If you're doing backups on the main server, and the logs have disappeared, then you can't send them to the mirror. But what you can do is decide to send the journal and do a backup on the mirror. What I usually recommend is to do a backup on the mirror because it doesn't block the main server. The only drawback is that if you have to reintegrate something, it takes more time because you have to recopy it from the mirror and put it on the main server in order to be able to recover the backup. The advantage here is that you have a mirror that has its own backup in v14 and that has its own journal. So if you do a backup on the mirror, it'll carry out the backup with the data that's in the backup, plus a backup of the journal of the mirror. So you put it back on the main, you start it up with a journal, and you're good to get, you can keep going. Just another question. Updating of the mirror structure, is that automatic or is it not automatic? Currently, we're looking at data. There isn't an update of the structure on the mirror. Or, one second. I haven't said this correctly. When you do modifications, the journal only carries the data, so the journal won't necessarily know that we've added a table, for example. However, if you're using the current system, there are the same restrictions, i.e. if you've changed the structure, you have to think of changing it on the mirror as well. That's when you're doing things yourselves. But in the mirror tool that we've thought of, there will be a system to detect structural changes. We haven't defined it yet. That's why the product isn't quite ready. It isn't ready at all for the time being, actually. There's a big part that's been written, but it's in separate APIs. We don't really know how to integrate it into the product yet, but it will be able to detect structural changes. It'll either recopy them or stop the mirror, because there are times when you want to stop mirroring. I don't know if that'll be useful, but there are times when you do want to stop mirroring. And in a more automatic mode, the structure will be updated. That's in the most automatic of modes. You're right, about rollback. There's another problem. For certain countries and certain industries, we legally have to do a backup, a periodical backup, either per day or per week, and to keep the backup for a certain period of time, depending on the company or on the government. So in that case, what would you recommend in terms of mirrors? Well, for you it doesn't change anything, but for the government, would they consider it to be the same thing? The mirror is a mirror of data. It's a copy of the data. So from a legal perspective, I don't see why that would be a problem. Whether you copy the data through the network or through another method, a copy is a copy. Hi, Laurent. Patrick Dorland. I just have a quick question. I have clients working on Linux, and they heard about 4D and Windows. You know, what a pity. Is there something that's going to be done on Linux? A long time ago, we saw a Linux server that you had presented. Laurent Hainaut spoke a bit about our operations. This year in the keynote, we didn't really have the opportunity to talk about the internal architecture. I don't know who was at the previous presentations, but well, for Linux, we've already been through a Wakanda server, it doesn't mean that we don't want to work on Linux. We like Linux, but there are things in 4D that for the time being are causing a few issues. As we've defined Wakanda, it's a server that's faceless, meaning it doesn't have an interface, which makes things easier for housing and so on. You can imagine a 4D server without an interface that would make things easier, make it easier to move to Linux. The graphic libraries, the design graphics are either based on Dro on Windows or on Quartz for Mac. I haven't done anything on Linux for the whole graphical area. So there are a few things that you have to take into consideration. The way the language written in cooperative, you go through fibers, meaning that you would have to create a system that doesn't exist on Linux. Of course, you could implement it. It isn't insurmountable. But, right, we are thinking about it. I'm not saying that it's not going to happen, that you'll never have a 4D server on Linux. What's just about sure is that when it happens, it'll come without an interface. Don't expect to have code that will enable you to open a window on the server. You're really going to need a programming logic where server administration will be done remotely. That's what's causing the largest delay in moving towards Linux. We don't want the server to be run on Linux, the 4D server that is. We're close, but really it's the server administration, choosing the parameters, the opening commands, the basic commands. For the time being, we don't have any remote code for that. We would have to do it with a web interface or through the client to control the server. So we've done a bit of it. There are a few things that you can see from a client perspective, for example, changing preferences, but there's a big part that isn't available. We're moving forward. Every time we rewrite pieces of 4D, and namely of the 4D server, we separate the back end and the front end. We separate them so that little by little we can implement Linux in, let's just say, a reasonable time frame. Just getting back to the backup, in V12, when you have a packaged operations, one of the problems with the backup is that you can't deploy it without going into the package to catch the preferential file. And now in V13, this was considerably improved, because beyond the backup, there was also the memory settings, the port and SQL. So we found that this to be a considerable improvement, because now we can save the cache, the memory, the port, etc. But we can't save the backup. So it's still not, meaning that you can't deploy. You can't give the client a package and say, will you replace this by this and it'll work. Will that be corrected in V13? Because in V14, we'd all agree that it would be very beneficial, but it isn't usable with our clients because they all have XP or D6.8. And so for us, I mean, we're looking at 2015. Microsoft has done a bit with XP, but Apple isn't really helping us out. So today, can we be sure that at a certain point in V13 will be easily for publishers be able to deploy a package through the client, not through us? Because today, we're the ones who are doing it. Well, I don't know. Maybe we'd have to ask the person who decided to keep the backups preferences. I think that those people aren't here. The idea is to outsource the settings of the server. I think that Laurent could speak to that. I don't think it's a problem, but I don't want to say too much. I'm just looking in the room to see if maybe there's someone who could answer your question. Really, I don't think that it's a problem, but I wouldn't want to say too much. The setting savings, and I'm just saying that, you know, we can do it except for the backup. Maybe just a final question. It's already 10:45. Hello. I have a question about the debugger when you're on the 4D server and you want to debug stored methods or potentially web methods. The use of the debugger is quite complicated because to access the server you have to be in a certain mode and so on. Would it not be possible to deport the debugger window to our clients? Well, there isn't anything that's been planned short term, but you're right, we had thought about that. In any case, if we're looking at a faceless server, that's something that'll be mandatory. We'll have to deport debugging to remote. But I'll admit that it isn't always convenient to have access to the server. We're working on it. And gradually, we're changing the internal channels of information transfer in order to be able to deport certain pieces. Just a final question. Nice brief question. I heard you talk about automatic updates of 4D servers and clients. Does this concern interpreted bases, or is it only for compiled bases? I think it's always for compiled. I don't think it's in order to interpret, it's only to compile, unfortunately. There are advantages to compiling. Well, if you want to be agile, it's true that there are bases that you may want to directly modify. No, you're right. You're right. Okay, I guess we'll keep waiting. And that being said, it's true that it's something that we can consider. More and more, we're thinking of deporting the update logic to external products, which would be much more robust than a script, and that would provide better functions and features, where at a first step, you can imagine that with more advanced technologies, you could do it more simply. The question was inaudible. You can imagine an application for compiled bases for a single user. The problem is that to do the upgrade, you have to be connected to the server. Maybe you don't need a 4D server, but maybe 4D would provide a new product updater. So an updater that would enable you to implement a server but not a 4D server. A software that would be able to receive requests to say, yes, I'd like to update a number of things with my clients. Right, these could be standalone bases. Well, that would be a whole other product. It would be very costly from a development perspective for us, but we'd have to move the 4D server logic to a new product that would be a product updater. When we're deploying our standalone bases, it queries the 4D server to find out what the last version is. Yeah, indeed, we could look at it. We could consider something like that. It's a bit more complicated because it's not a local resource cache, but you're right, it's something that we could think of. I guess we could put it in our to-do list. Okay, thank you very much. Thank you for filling in the questionnaire.